This is Rajesh from Sankyampuram University. Currently I work with ClaB-Build. This presentation is on code in a box. It is not giving details about code. I believe just now we finished the talk from Madhav. He has given a classic and very good presentation on the basics, how to start with the code. Now what is code in a box is basically it's an environment, it's a tool. It's an environment where I can develop service. Installing a code and then doing the stuff, that is one way, this is another way. So what is all about? That is what we are going to. Yeah. We start with the motivation and benefits of CiaB, code in a box. In short, we call it as CiaB. And we flow through the code in a box, the basic know-hows. Here, little bit of whatever Madhav has said, very little I'm going to touch it, but I'm not going with the details of that. And then I started working with code in a box 1.0, the initial version. But the initial stable, I should say, was 2.0. So 2.0, then how I migrated to 3.0. So a little bit of that I'm going to touch it, and at the end, I'm going to end this presentation or this talk with the basic code structure. When we download, what's the code structure, where to develop the code, where it resides, and then how to build the basic prerequisites for making the CiaB setup, and then build steps. So this is what is the total overall stuff we are trying to show here. Let's start it. Yeah, the motivation. What exactly is the motivation of CiaB? Why we are? It is an empirical and economical code-pod simulation. Empirical because we are doing research. So for research, so far whatever we heard from Dr. Guru and the other talks, we have seen that they are giving the theory, because first we should know what exactly is that. So that's the theory. Now once we know what exactly is that, we have to sit and start developing the stuff. Development will fetch us the results. Experiments, that's what is empirical. So if we say empirical, yeah, that's what, empirical. And then is the economical. Why economical? Because ClaB-Pod, if I need to install, it requires quite a bit of hardware and it requires again money. But for this ClaB-Pod simulation, what we require is just $2,000 server or $2,500. This server, we use with this server. That's all. In this single server configuration, we can really start developing our COD services. So that is one thing. And it has one more beauty that I'll come here later last. Also, why we are working with this? Because we have these all technologies. We all know, we might have heard most of these. Anybody working with the cellular network, slicing is not new for them. So yeah, that's the thing. Microservices. These all are the talk of the town. And why exactly we are doing this single server? Because this is easier for dev, test, debug cycle. This is a single cycle which we continuously iterate on. So that's the basic motivation why we go for this CiaB. Yeah, so one last point is this access agnostic cloud. Actually, it is not that access agnostic, but in some profile, like for our code profile, they do not care about the access. They do not care about the access. They give a workaround where we can inject the packets and just work on the core. Like I'm a core service guy, I want to develop a core service. I should not bother about how access is working, who is giving me the access, these things. So, yeah, that's why it is access agnostic. So if I need to work only on core, it's best. It's really best. And things are, it's like whatever you develop here, change. So these are the basic motivations which make CiaB a compelling one. Okay, what's the benefits? First and foremost, it's polymorphic. What is polymorphic? It's like multi-shade. This setup, even in slide number 60 of Madhav or slide 20 of Dr. Guru, these all things are same. And even Dr. Guru also said similar thing. What the essence here we are trying to say is, these things remain same. These all, residential version, cellular version, enterprise version, or whatever we are coming up, these all are different flavors. We call it as profiles. Now we started using the word manifest. So I'll talk about those. So profiles, those all are polymorphic. That means same setup, You choose whichever flavor network you want, start working on that. So corresponding to residential network, automatically the residential VNFs will come. Cellular VNFs. Enterprise VNFs. So ultimately, setup is same. CiaB setup is same. Just choose which profile you want. Automatically the configuration of VNFs will be there. Start working on that. It's as simple. That's why I call it as polymorphic. And then, yeah, if I need to start working on only developing a service, I just want to do an orchestration, because the word orchestration is something for a new developer. Whoever starts working on orchestration, this is a very loaded word. They don't see it, but I believe seeing is believing. So I need to develop something. How? XOS is the best way to start with. That is what we call it as orchestration. So XOS is a very simple, beautiful piece of code through which we can understand how orchestration works. So a service is created and an orchestration is done. So those are the simple benefits. And finally, it's a single server configuration. We really need not have multiple hardware. We just need one server, a Dell server we are using with some 12 cores. The requirement is there in Wiki. So just get that server. It's hardly $2 to $3K. That's it. That's it. You don't need anything more than that. And what we develop is something like this. Some guys who are interested in developing access, they will focus only on access. If we are working on core or some data plane, yeah, we do only this. So whoever is doing some the domain, whichever domain, it's easier for them. Yeah. Okay. Now the basics. Again, this is not in depth. It is just at a superficial layer. We start with, there are multiple domains. These all are called domains. This is again the terminology what we use in cloud or here in CiaB. In simple terms, we call it as a VM. A VM is nothing but domains. These all are called domains. There are these many domains. The running domains are very clear. What is the need of these? We need to develop something and at the same time press F5 to see, okay, whatever I changed, yeah, here it's changed. So it is called continuous integration and continuous delivery kind of stuff in a very, very blunt way, I can say. For a developer, actually we can say that whatever I want to do the development, I would like to even integrate in the GitHub or anywhere, or I need to deploy it straightforward and see. So this is the development environment. I will install all my toolchain here. And once my toolchain is installed and I make all my changes, do a make or kind of stuff, it will be pushed, deployed onto this prod VM. This is what we also call it as a head node. So everywhere this is the starting point, and everywhere we deploy here. In Matthaw's slides, it was very clear that everything is running on this. And only VMs or kind of stuff we are running on the compute node kind of stuff. So this is the foremost thing to see how things are running. And leaf spine architecture, yeah, this is the trellis part, but in CiaB, this is light. This is not doing much stuff. Compute node, this is the fourth part, that is this one. Currently, the CiaB has been tested with one compute node. CiaB 2.0 goes with even 3.0 goes even with 2 compute nodes. So, but currently the testing is done only with one compute node exhaustively, and it's working well. So yeah, that's what I have mentioned here. So in these compute nodes, basically the VMs are installed. So VMs, the services, they can run in VM, or they spawn further within VM. They spawn containers, Docker containers, and then they OpenStack. Basically, they run on the LXD machine. The LXD container is straightforward, not on Docker. Yeah. Now, Mathav also mentioned that there are like 16 to 18 technologies or different pieces of open source which make the code. One of those is MAS. So what exactly is a MAS? In a very simple layman terms, when I boot my PC, I need to get my IP address. Similarly, if I get a PC, I need to install the operating system. So, okay, I fetched a compute node. I need to, in simple language, I need to format it, put the Ubuntu and make it up. Who does that? MAS does that. So that is what is called MAS, Metal as a Service. This is a canonical service. So it does that job. Simple, boot a compute node, install the Ubuntu and make it ready for further use by code. So that we can say in a very blunt way, that is the basic job of MAS. It has many other services which are daemons. These all are daemons. These all are also running in head node. It looks like this. When I run my, when I configured my compute node, the name of my compute node is this. Automatically CORD attaches this suffix CORD.lab. This is my silent underscore writing is the name of my compute node. So yeah, these are, it has the Ubuntu 14.04. Yeah, this is the configuration. So MAS. And these all are the basics of MAS. So MAS, all these services, they take care of when a CiaB starts or when CORD starts, how to get the IP, how to see if new switches are coming, eventing. So all those are done via this. So that's the basic of the MAS. Yeah, this is the head node. Head node, what today we saw, most of the things are running in head node. What all things? Your XOS runs in head node. Your these fabric, the ONOS instances, 2 instances, overlay instance, underlay instance, MAS, all these containers, yeah, they are running. Maven repository, where all the CORD applications, apps, AAA, all those, they are in Maven repository. Now, this is where your OpenStack is running. This also runs in the head node. So all these basic services are run under this LXC containers. So head node is the basic start where we deploy all these things after build in CORD dev. Those are installed in the head node and we start. It is basically a VM and all these other containers. Yeah. So final takeaways, whatever we have seen, it's a single server configuration, simulation. XOS is the NFV orchestrator. ONOS takes care of the flows and all those. They are spawned in Dockers or VMs. OpenStack services in LXT. Each service we say it's running in a slice. Guru already gave the definition of a slice. And yeah, it's basically a set of VMs and VMs. And the service dependency graph. Even Guru said why we call it as a graph rather than a chain, service chain. So these are the things what we can, this is what we develop in CiaB. These are some of the things what I could see the basic differences. There are so many, I couldn't capture more. But yeah, these are the basic differences between 2.0 and 3.0. So starting from how to log in, what was there previously. I even know many guys who are working on CiaB 2.0 because their setup is up and running. So these commands are changed, so maybe you can refer this later, or you can ping me for also. Yeah, community is there, they are awesome, they are going to help us a lot. Now build system also has changed. This was the 2.0 build system. This is now, they moved it to Ansible completely. Playbook based on 3.0, and now in 4.0 again they are moving to make based. So these are the commands through which you can do, and again from Gradle they are moving to make. So 3.0, these are the commands. Code structure. Here I am planning to spend a little bit of time because we developers, we have to start writing our code somewhere. Where if we are on CiaB 2.0 still, this is the code folder structure. Earlier we used to use the repository service profile, now we are not using service profile. In 2.0, we used to call each flavor, each M, R or E, like mobile or residential or E, all those, we call it as profile. So all those profiles are there in this service profile folder, and we take the CORD folder. Here we make our config files. This is the in files folder, there is a config, there we write the basic configs. The synchronizers.yml, yeah, we need to write the synchronizers. If I write a new service, I'll add that in the make file, and that we start building. Now the code for that new service lies in the XOS services folder. I create a new service here, and these are the REST APIs, task interface, and the synchronizers. Yeah, Matav's talk, these things were very clear. If we attended Matav's talk, these things can directly be correlated whatever he said. Because of time constraint, he couldn't go to the code structure. Yeah, that's why I'm showing it here. And then finally, when we create a new service, there are quite a few services which are running. I need to tell to the subsystem that please onboard my service. How would I tell it? I'll tell I have the onboard.yml, my service, I create this file, and then I write it on that, okay, please boot it up, start it. And what to do after that? Those are the roles. Those are the roles. What task it should do. So in synchronizers folder, we write the Ansible scripts. These are called recipes, playbooks. Yeah. So we write that, which actually does the thing at the back end. This is the back end. This is the data model part, the how to exactly, and this is the REST APIs, whichever are open for users to configure. These are newly what we have created. So legends are probably clear. So this 2.0. Now from 3.0 perspective, a little bit of things have changed. Now we are not using anymore the service profile, we are using the platform. This is a new repository. First change. Second change, we stopped using the word profile basically because we now call it as a manifest. We write manifest, and those manifests are like R chord manifest, M chord manifest. So those manifests are actually which we are running straightforward here. So he also explained there are three things. One is the front end, other is the mock, one is single, and our last one is your chord. So we can use mock or we can use single. For my case, I used single. It's fine with me. Or mock is also fine. So I modified even this rchord.yml. I included my new service in this. So these are the facts. These all are the Ansible. So I said that we need to write the Ansible for onboarding my service. These things are still same. These things are still same as 2.0, but the build system has changed completely from 2.0 to 3.0. Second thing, synchronizers, yeah, other than those, we write the roles here. But now again, there is a discussion happening whether these should be kept here or corresponding to the service, shall we move it here? Those are what we are going to look in, probably 4.0 or what, but that is still to be there in the next release. So currently this is the thing what in 3.0 it was. So we develop our new service here. We write our code here. These are the basics of what we have. And today, if we want to know what is Xproto and all those, yeah. So we just write the new part of this, and the compilation of XOS code will take care of this. So after Matthau's talk, if you attend this, you can easily correlate. Once again, I'm saying sorry to repeat, but yeah, that's the brilliant example where we can understand what those basics are, and this is a practical. Like I develop the code, how to write it, where to write it. These are the places where I write the thing. These are the new things which I'm writing. Okay, now the things like if we have a plain system, how exactly to start with, these are the basic things what we need to install. These are the prerequisites. This in my system I must have it before I install CiaB. So these are not enough, but yeah, almost 80% of requirements I have got here. We need, like for these probably we require some repositories, so that from net we can easily get it. So just add those repositories, sudo add, and then do this. We need to have a blueprint. And if by any chance you already had a version of 2.0, you would like to migrate to 3.0 kind of stuff, sometimes it doesn't work, delete your chord folder and delete these folder manually, and then start using this command. It will install and do everything. Also, there are some issues we face with mass provisioning. We face sometimes the build stops. Those are intermittent. Even the ON.Lab guys in ON.Lab, they know this. But simple thing is give a build second time. No big deal. Yeah. There are some here or there problems. Those you can see in community. Those are very well addressed. Very well addressed, and probably you may not face much problem with 3.0 and onwards in configuring CiaB. On at least on x86 server, it's pretty good as of now. And one thing is, if at all we want to, there is a command like -c. If we give a -c, it will clean and start building the thing. Otherwise, we can manually clean by using these commands. Manually clean all the VMs, all the domains, run these commands, clean the things, and we are good to go. We start just doing this. We don't need this also. Just do it. If second time, if the build has broken somewhere, just remove this -c. Don't forget to remove this -c, otherwise it will again clean and start building. So we will always start from 0. So that's it. Yeah, then compilation. When we see the compilation, it's currently taking like huge time. They are well aware of it. So there are some things going on. But yeah, when we compile, this is the sequence which goes. It's a huge install.bat file, whatever it captures. If you really analyze how things are going in what sequence, this is what it happens. It first clones the repositories, fetches the images, build it. That is what even Madhav said. We pull the things and then we deploy it. Yeah, so this is the first step what we do. And then, yeah, this is the deploy base. It starts when each component is deployed. The last one is your access. And finally, we start with the provisioning and tests. So in their default code in the box script, it automatically does an end-to-end testing also. This is a playbook separately running. If we want to make our new service and test it, we have to write our script and do. So probably this we will try to make it more easier for developers to test. Like if I develop my service, I can make a new Ansible script and do the things. Yeah, this scripting, if I can make a little bit easier, it would be good for developers to test their service immediately. So that is one thing. So that's how I basically create my service. These are the places where I saw like how to create my service. I'm assuming that 3.0 is there. So this is where I create my service, and I need those kind of prerequisites to install CiaB. Just run that command, this command, this one, and we are good to go. They are setups there. So it's that easy. For developers, it's that easy. Here, if you want to take the master, you can change this to master, you'll get the master. But I recommend to go with the stable branch. Like now, next week, we probably will get 4.0. That's quite stable, I believe. Yeah, we can start with that, or this. And then these are the things. And testing, we have to write our scripts. So this is complete. Test, develop, test, debug. Debugging, it's completely an ELK stack. Already Mata has connected or talked about that. I didn't include that in my slides because again, that's a huge complete stuff to talk about. So time is a little bit a problem. So that's it from my side. If you have any queries, kind of things.
Maybe I missed it, but which is the minimum hardware requirements?
Only the server. Just plain that server. That's
how much RAM?
Around RAM is minimum 64 GB. Minimum 64 GB RAM. Yeah. So this entire configuration we get for $3,000. Dell server, Dell Power Edge, R730 or any of those. They cost around $3,000 and everything is there. We just need to run their script. That's it.